Hey guys, how you guys doing? Hope you guys are all doing great. Welcome to today's third live for GCSE Mathematics at ExamSolutions. My name is Michael. In case some of you guys are just meeting me for the first time, I have been working with Stuart for the last couple of months to help with the GCSE side of things. Um, Thank you guys very much for joining today. We had a couple of technical issues on Wednesday, but anyways, hopefully today's session goes smoothly. Today we're going to be looking at probability today, so we're going to be looking at quite a few questions involving different types of probability. So get your pens out, get your questions ready. We have Stuart, the ExamSolutions guy, who's going to be helping out on the chat. So feel free to ask questions as we go along. And definitely participate. I'm going to be asking you guys questions, so get involved and let's see how you get on. Okay, so without further ado, let's get straight into it. And let's go. Okay, so we're going to kick off today's tutorial by looking at some sets, set notation, and seeing how we can combine that with Venn diagrams to calculate probability. So let's look at a couple of really important symbols that you guys need to know. So this upside down looking U represents what's called an intersection. Okay, some keywords associated with the intersection are the keywords and both. Okay, and the operator, which is commonly associated in statistics and probability, is multiplication. Okay, the union. Okay, so just the U shape here. A keyword which is associated is the word or. Okay, and a common operator associated is the addition operator. Okay, so hopefully you guys should be familiar with how the set A union B looks on a Venn diagram. Okay, it's just the shaded region for A or B. The intersection is simply the intersection between A and B. Okay, so it's the part which both the sets share in common. Okay, next on. All right, so here we have the set A union, and this dash here represents not. Okay, so it just means not B. And how I illustrate this is by taking them separately. Okay, so if we were to shade the set not B, this is how it would look. Okay, so that's just everything outside the set B. Okay, and using the operator, because we have the union sign here, if we use the operator of addition, all we need to do to get the rest is simply add the set A. And therefore, the set A union not B is represented by this shaded region. Okay, and lastly, we have not A intersected with B. And this is how it looks. And it's kind of hard for a lot of students, including me when I was a student, to get my head around intersections with sets and what are called complement sets, not A. Okay, so how I approach this is I break it down. Okay, let's break it down. So we draw two different Venn diagrams and we simply just shade each individual set separately. Okay, so how the set not A looks on the Venn diagram is as follows. As you can see, so we just shaded everything outside of A, and the set B simply looks like this. Okay, so if you guys remember, one of the words that we associate, the key words we associate with the intersection is the word both. So a way you could get around doing this question is simply look for the region where both diagrams are shaded. Okay, and hopefully you guys should be able to see that it's this region here. So this is a slower but a kind of clearer way to easily depict intersections between complement sets and just standard sets. Okay, so we're going to go ahead and do some questions now, and let's see how you guys get on. Okay, so A and B are two events. Some probabilities are shown on the Venn diagram, as you can see here. The question is, work out the probability of A union B. Hopefully you guys should be able to catch this one quickly. Let's have a go. There is a little bit of a lag, so it might take me a few more seconds to see your answers. Is there anyone out there that can calculate the probability of A union B. Should hopefully see a couple of answers streaming in soon. Hopefully shouldn't take you long. Okay, so we've got one from Bushy, comes in with 0.8. Adam as well, 0.8. Marcus as well, so the usuals. Good to have you guys on, always participating. Anyone else want to get involved? We've got Din as well with 0.8. And I think it's fair to say you guys are correct. The answer is 0.8. So how you could look at this is that the set A union B is represented by this shaded region, as we saw earlier, and it includes the probability 0.3, 0.15, and 0.35. So we simply add up the probabilities to get 0.8. Okay. So as you can also see, I've also just filled in the Venn diagram. Okay. Using the fact that the total sum of probabilities is equal to 1. Okay. Let's have another question. Good stuff, Bushy. Good stuff, guys, for coming in there. Let's have a go at this question. What is the probability of A union not B? The probability of union will not be. In case you guys have just joined, we're doing some set notation questions, and we're calculating probabilities by hopefully determining the region to which the sets occur. Okay. So we've got 0.65 coming in from Adam. We've got Bushy as well. Anyone else? Okay, I'm pretty sure you meant 0.65 there. Give you the benefit of the doubt as you're currently on 100% at the moment today, Bushy. We've got Marcus coming in with 0.65, just being a bit pedantic there. Okay, let's go through this question. So the set A union not B, as we saw before, can be represented by this shaded region, okay, which includes the probability 0.3, 0.15, and 0.2. Okay, so adding all of these together, we get an answer is 0.65. So good stuff, guys. Good stuff, guys, for coming in there with that. Let's have a look at another one. So here we have, they've asked us to calculate the probability of not A intersected with B. How do we do this? What's the value? And well done for so many of you guys who are getting involved. Set notation is something that comes up in A-level as well. Okay, so it's really important you understand how to depict sets using Venn diagrams and shading the correct regions, okay? So Sonal says he doesn't get it. Okay, what exactly do you not get? So what we're doing here is we're looking at the set, okay? And we're trying to see which region it represents on the Venn diagram by shading it correctly, okay? And once we do that, we then find the probability of that set by just simply using the probabilities that we find inside that region, okay? So we've got some answers coming in. We've got 0.7 from Delboy. Marcus Oliver comes in with 0.35. We've got Bushy there with 0.35. So the general consensus is 0.35, and the answer is 0.35. So Sonal, in case you didn't get this, so, and for everyone, so the set A, not A, intersected with B is represented by this shaded region here, okay? So the probability is simply calculated by just collecting the elements, okay? In this case, the element is a probability which is inside that region. So it's equal to 0.35. Good work, guys. Good work, everyone, for getting involved. And last but not least, let's see who can get this one. So the probability not A and not B? Who's got any ideas of how to do this one? So think about, you can even look at it literally. What does not A and not B mean? Okay? And where is that region on this Venn diagram? Or you could simply use the method that I showed you earlier. Okay, we've got some answers coming in. 0.2, 0.2s. We've got 1 over 5 del boy. Okay. Good stuff. Okay. All good. Well done, guys. The answer is indeed 0.2. Okay. So as you can see, the set not A intersected with not B can be represented by the shaded region, which is outside of, in fact, the union. Okay. So what we could do is do 1 minus 0.8 to get the answer of 0.2. So that's fantastic, guys. Well done. We're all smashing it. That's good. We're going to move on now. Okay. So the next few questions will hopefully help us calculate probabilities for dependent events and independent events. We're going to be using what's called the and/or rule to calculate specific probabilities, and we're also going to be using some probability trees. Okay, so let's have a look at this question and see what we can do here. Okay, so this question. So there are green and blue counters in a container. Kevin takes a random counter from the container. He replaces the container in, he replaces the counter in the container. Kevin takes at random a second counter from the container. Complete the probability tree diagram. Okay, so guys, once you're done, just say done. Okay, have a go at this question. So we're just doing the first part, okay? Just the first part. Thanks, guys, for coming on. So we've got Del Boy who says he's done. Good stuff. All right, so I'm going to help you out with this one in case you guys are not done. So one of the general rules of probability trees is that the sum of branches must equal 1, okay? Now, here we have the probability of green is equal to 7 over 8. Therefore, the probability of blue must simply equal to 1 over 8. Okay, so that should be pretty simple. Now, the next part of the tree is really where we need to pay attention. So we're told that he replaces the counter in the container. So what does that mean? It means that really the sample space, another way to define a sample space is the set of possible outcomes, set of all possible outcomes. That doesn't change, okay? Which means that the probabilities won't change, okay? So the probabilities remain constant. Another way you can define these events is as independent events, okay? So the probabilities stay the same. Okay, now, guys, let's have a go at the last question here, which says, work out the probability that Kevin picks counters that are different color. So work out the probability that Kevin picks counters that are a different color. So we've got Marcus coming in with 14 over 64. We've got 7 over 32. So Adam's just simplified Marcus down. Good stuff. We've got Din coming in with 1 over 6. Colin 14 over 64. Guys, rolling through the answers really, really quickly. Hope you're checking your work. I'm going to tell you if you're right in a second. So Din just changed his mind. He's gone for 7 over 32. Fair enough. And we've got Bushy coming in with 14 over 65. And, okay, 64. All right. Okay, so good stuff. Well done, guys, for getting involved. It's always good to have you guys really getting involved and, participating. All right, so let's have a look at this question. So um, we've been asked to work out the probability that Kevin picks counters are a different color. Another way you could say this is, well, what's the probability of picking a green and a blue, or the probability of picking a blue and a green? Now, what's the significance of rewording questions? Well, hopefully here you can see the and or rule come into play, okay? Where, as mentioned previously, and represents multiplication and or represents addition. That's a general thing in probability and statistics, okay? So using the tree to calculate the probabilities, as we have the probabilities on each branch, we can go ahead and simply find out that the probability of getting a green and blue and the probability of a blue and green is equal to 7 over 8, okay, times by 1 over 8, plus 1 over 8, so the plus comes from the or, 1 over 8 times by 7 over 8, okay? And that gives us a final answer of 14 over 64, simplified down to 7 over 32. So well done, guys. You guys are really getting in there. Good stuff, okay? So this is a typical example of probability with replacement, and it's pretty clear by the question, okay? We're told that he replaces the counter in the container. Good stuff, guys. All right, let's move on to another type of question. Let's see how you get on with this one. So we're told that there are 5 red pens, 3 blue pens, and 2 green pens in a box. Gary takes a random pen from the box and gives a pen to his friend. Gary then takes at random another pen from the box. Work out the probability that both pens are the same color. Well done, Sonal, for getting that one right. Let's see how we get on with this question. So what makes this question different from the other questions? So that's the only clue I'm going to give you here. See if anyone can come up with some answers for us. Probability questions can be a little bit daunting, but once you put everything into a category, I promise you, it'll be a lot more easy for you. So we've got Adam coming in with 21 over 45. Okay. Yeah, I mean, thanks, Stuart. He's asked you to give your answers of an exact fraction. That just makes our lives a lot more easier to read your answers. So we've got Colin coming in with 28 over 90. Bushy the same. Anyone else? Anyone else want to get involved? Anyone else think differently? Or the guys that have given their answers, are you 100% sure you're right? Is it usually stats on Friday? Well, really just depends on, yeah, it just really depends on what you guys request, okay? So definitely request some topics in and we'll be sure to try and cover those, right? All right, so Adam's just come in with 14 over 45. All right, so let's have a look at this question. Good work, guys, for getting involved. Let's see what we do. So just like the previous question, I would always recommend that you define the probability, okay? So the probability that both pens are the same color is the same as the probability of getting 2 reds or 2 blues or 2 greens. Okay, so hopefully you can see where this and or rule is going to kick in again. Okay, now unlike the previous question, we're not given the probabilities of each event. Okay, so we need to go ahead and calculate them. All right, so as there are 5, 3, and 2 pens in the box in total, there are a total of 10 pens. Okay, so the probability of getting a red is equal to 5 over 10. The probability of getting a blue is equal to 3 over 10, and the probability of getting a green is equal to 2 over 10. Okay, now the next stage is really to go ahead and calculate the probability of R and R plus blue and blue plus G and G. Okay, however, we need to be careful, all right, because in this question, we're told that Gary takes a pen at random from the box and then gives it to his friend. So because he's taken the pen out of the box without replacement, in this case, the sample space changes, okay? All right, the sample space changes, meaning that basically the probability will change, okay? So as he's taken one red pen from the box, okay, there's going to be 4, right? So that's going to mean in total there's going to be 1 less pen, okay? And that's exactly why the numerator and denominator decreases by 1, okay? So the probability of getting an R and an R is going to be 5 over 10 times by 4 over 9, okay? And we do the same thing for the probability of getting a blue and a blue. And the same for the probability of getting a green and a green. As you can see, each time the numerator and denominators are decreasing by 1, okay? So summing all the probabilities together, we're finally going to get the sum is equal to 28 over 90, okay? Which can also be simplified, okay? So well done, guys, for getting it right. An important point to make, finally, is that I'd recommend that you do not simplify during the question, okay? Because using this same logic of reducing the numerator and denominator by 1, imagine what would happen if we had simplified at this stage and we had half here, okay? We'd reduce the numerator by 1, which would give us a probability of 0 on the second try, okay? And I think it's pretty obvious to see that once we take a red pen out of the box, there's going to be still 4 more red pens in the box, right? So the probability of getting a red pen is obviously not going to equal to 0. Okay, so that's a typical question of probability without replacement. Okay, so great stuff, guys, for getting involved. I can see that it looks like Adam. Was that Adam there who got that right? Bushy as well. Good. Bushy's got 14 out of 65. Not quite. 14 out of 45 works. Good stuff, guys. Well done. Really, really well done. Okay, we're going to move on. Okay, so the next few questions are going to deal with probabilities involving group data. Okay, so we're going to be looking at what are called group frequency tables and also histograms. Okay, so pay attention, guys. Let's have a look at the next few questions. All right, so the tables show information about the weights in kilograms of 40 babies. Okay, so you can see they're represented here. One of the 40 babies is going to be chosen at random. Find the probability that the baby has a weight of more than 5 kg. How do we do this one, guys? This is a different distribution to what we've looked at before. How do you calculate the probability for this type of distribution? So we've got Bushy coming in with 3 out of 40. Anyone else? Adam coming in with the same 3 out of 40. We've got 3 out of 40 for Marcus as well. The usuals. Good, guys. Does anyone else want to get involved? Don't be intimidated. Give it a go. The best you can do is try, you know? Anyone else agree with Bushy, Adam, and Marcus? What do you think? Is it 3 out of 40 or is it not? Del Boy the same. Good stuff. All right. Okay, so fractions are exact by definition. No, yeah. You guys are given the correct in correct form, and very, very well done. Okay, so first of all, we should observe that this is what's called a grouped frequency table. Okay, um, now you can see this because all our data is organized and separated into what are called groups or classes. Okay, where in this case each class is a weight class. Okay, so how you'd read this is there are 12 babies that have a weight between 2 and 3 kg, 16 babies that have a weight between 3 and 4 kg, and etc. Okay, so because we're dealing with a slightly different type of distribution, we need to look at a slightly different formula. It's a varied formula. It comes from the same general formula for probability, but for group data. Okay, so this is desired frequency divided by total frequency. Okay, now first of all, let's define what we're looking for, the desired frequency. So looking at the question, they've asked us to calculate the probability that the baby has a weight of more than 5 kg. All right. So in this case, it's simply going to be the number of babies with a weight more than 5 kg. Okay, that's what we're looking for. So how do you do that in this type of question? So you first of all highlight the class that is desired. Okay, so a weight greater than 5 kg, you highlight that class. You then simply sum up the frequencies which are within that interval. Okay, so 1 plus 2 or 2 plus 1 is equal to 3, and we've simply found our desired frequency. Okay, now to find the total frequency is really, really easy. Because it's given in the question, we're told that there are 40 babies, and another way you can calculate the total frequency is by simply summing up all your frequencies in the table. Okay, so the total frequency is equal to 40, and therefore our final answer for the probability of babies that weigh more than 5 kg is equal to 3 over 40. So well done, guys, for getting that right. Some of you on 100% today, like literally smashing it, right? Let's see if we can carry that all the way through. Keep it up, and if you don't understand anything, feel free to ask a question, okay? So the next question is a follow-up from the previous question. And this time it says 2 of the babies are going to be chosen at random. Find the probability that both babies have a weight of less or equal to 5 kg. Interesting. How do we do this one? Yes, well done, Sonal. It was 3 out of 40. Well done, Din, as well. Del Boy, good stuff. Take your time. Slow and steady wins the race, okay? Accuracy is always more important than speed. But I want your answers in 30 seconds. All right, cool. So Sonal, 37 out of 40. Interesting. It's an interesting answer. Anyone else? Just bear in mind that this time we've chosen 2 babies. So Din comes in again with 37 out of 40 as well, okay? Seems to be a general consensus. So Sonal's backtracking a bit. That's cool. It's fine. You got time to go back and reevaluate. Del Boy again, 37 out of 40. Okay. All right. So the first differing answer is Adam, who comes in with 111 out of 130. And we've got, okay, so we've got Bushy with 333 out of 400. Interesting. Hey, Amy, how's it going? Feel free to join in. Have a look at the question. Whoa, so we got Sonal with 1369 over 1600. Wow, I'm going to need my calculator for that one. Not saying you're wrong. Okay, so some people are changing their answers. Some people have reevaluated. Some people have reevaluated. Okay, it's time to go through this question. So we got some huge answers here. Cool. I can't simplify some of those in my head that quickly. So you might be right. Hopefully Stuart can help me out there. All good. Okay, so let's have a look at this question. All right. So we're going to start off again, just as usual, with defining um, the weight. Okay, so we're going to define W to be the weight of the baby in kg. Okay, so from the previous question, we found out that the probability that W is greater than 5 is equal to 3 over 40, as so many of you did correctly. Okay, now using the fact that the total sum of all probabilities is equal to 1, right? Looking at what they've asked for, the probability of the weights being less than or equal to 5, well, we can simply say, well, the probability of that weight being less than or equal to 5 is equal to 1 minus the probability of W being greater than 5, which is equal to 1 minus 3 over 40, okay, which is equal to 37 out of 40, okay? Now, if you find it hard to get your head around that, don't worry. You can still use the same method as we used earlier, okay, which is simply just highlighting the interval we're looking for, which is all the weights which are less than 5, okay, and just summing up those probabilities, okay, and you will get 37 out of 40. Okay, so initially a lot of you guys came up with this answer, 37 out of 40. But if you read the question, you'd see that we're told that 2 of the babies are chosen, okay? So you've got to be careful. We've got a sample of 40 babies and 2 have been chosen. 2 have been removed from that sample. So what's going to happen to the sample space? It's going to change, okay? So this is another example of dependent probabilities, okay? So how you deal with this is you would let R be, say for example, we let R be the event that a baby weighs less than 5 kg, okay? Which we've already calculated the event of 1 baby weighing less than 5 kg. To calculate the event of 2 babies is a probability of R and R, which is going to be equal to 37 over 40 times by 36 over 39. Now, as you remember, when we're dealing with dependent events, okay, we subtract 1 from the numerator and the denominator, giving us a final answer of 111 divided by 130, 111 over 130. So a lot of you guys came in with that eventually. I see, who was the first one onto that? I think it was Adam. Well done, Adam, and well done the likes of Din for first, you guys looked at your answers and then read the question again and reassess. That's really good. That's really good. I always encourage you to always just question yourself when you're doing questions, okay? So there's a slightly trickier question there, but well done, okay? So here's the last question of the day, all right? And it involves histograms, okay? So here we're given that the histogram shows some information about the weights of a sample of apples, okay? So you can see here we've got a histogram. We've been asked, work out the proportion of apples in the sample with a weight between 140 grams and 200 grams. Okay, last question of the day. Let's see if we can all get this one right. Okay, so I've included some formulas which should hopefully help you out here. And it has some similarities to the last question. Some similarities. Finding it hard, Sonal? Well, you can always rewatch the videos, and also we've included some really useful links made by the ExamSolutions guy just in the description, all right? So if you're having difficulty, probability is always a hard one to get your head around. Took me a while to get my head around it as a student as well, so you're not alone there. Nice to see you on, David, again. It's running slightly over time. No worries. Always happy to help you guys. Always just keep communicating with us. Tell us what you want. Try our best to produce those for you guys. Let's see who's gonna come with the goods for the last question of the day and the last question of the week, man. Thank God it's Friday. Let's see who can come through with this. It's important you know how to interpret histograms at GCSE level and A level as well, okay? Giving you a really, hopefully a useful formula at the top right hand side corner, okay? Anyone out there with some answers? The hardest thing is to read the figures from the graph. Yeah, it can be hard. It can be difficult, but I'll go through it and hopefully it will make a lot more sense to you how we go about this type of question. Anyone with any answers out there? Give it 30 more seconds. Tick tock. Anybody? Is this one a no-show? Oh yes, we've got 33.2% from Sean. Not saying if you're right or wrong, but I'll tell you afterwards. Anyone else? 27 over 37. Okay. Anybody else? So 27 over 37. So Katerina. Is that how you say your name? Katerina. Katerina. Like the name. Hopefully I'm pronouncing it correctly. So we've got 342 over. Whoa, I've never seen that type of probability before, Del Boy. Del Boy, have a look at your fraction there. Looks like it seems to be like it's larger than 1, okay? Okay, all right. Thank you guys very, very much for participating in that. It's time to go through this, okay? So we've been given a histogram and we've been asked to calculate the proportion of apples. Okay, another word for proportion in this context is probability. Okay, now a histogram is another way of representing group data. Okay, so we're going to use this formula here in order to calculate the probability. But in order to do that, we need to, looking at what we have here, we can't get the frequency. Okay, so let's use this formula here to calculate the frequency, as we've been given the frequency densities of each class. Okay, so in case some of you guys don't know, the class width is simply just the distance between the lower and upper limit of a class. Okay, so let's first of all highlight the different class widths. So as you can see, between 100 and 140, the class width is going to be 40. Between 140 and 160, the class width is equal to 20. Now let's then highlight their respective frequency densities. Okay, so as you can see, all I've done is written out the frequency densities, just highlighted it, that's all. Okay, and now let's go ahead and calculate the total frequency. Okay, now the total frequency is simply calculated by calculating each frequency and adding them all up. Okay, so doing that, we're going to get, for example, 40 times by 0.12 is equal to 4.8, and that's going to simply come from this bar here. So the class width for 40 times by 1.2 is equal to 4.8. The next one we have is 20 times by 0.36 is equal to 7.2. Okay, and so on. Okay, and to calculate the total frequency, all we do is add up all these frequencies and we get a total frequency of 44.4. Now we've got the denominator of the probability. All that remains is to calculate the desired frequency. Now, the desired frequency always comes from the question, okay? So we're looking for the sample of weights between 140 grams and 200 grams, okay? So the way you should do this is really just highlight this, okay? Highlight this on the histogram and then calculate the probabilities, or the frequencies rather, that fall within that interval and sum them up together. Okay, so here you can see we've got a frequency of 7.2, which was calculated here, a frequency of 14 between the 160 and 180 class, which was calculated here, and a frequency of 11.2. Adding all of those, we get our desired frequency of 32.4, and finally giving us a probability of 32.4 over 44.4, which is equal to 73%. Okay, approximately 73%. Okay, so hopefully that was understandable for you. It was a slightly more tricky one. It was slightly more involved. But it's again testing this idea of calculating probabilities with group data. Okay, and this time we had to go a slight step further to calculate the frequencies instead of just reading it off a table. Okay, so that brings us to the end of the session. I'm just going to pop on here. All right, guys. Thank you very much for joining us today. Really grateful to have you guys on, participating, asking questions. We are going to take a break for the weekend. I'm going to take a break. Very happy to have you guys on, as always. If you guys struggled with anything today, please have a look at the links below in the description. If you enjoyed the lesson today, please just drop us a like. Join our Facebook group. We've got all the links. We've got a new Instagram page in the description, so follow us there. Ask questions, request some topics. We've got Stuart back on Monday, I believe, at 10 o'clock. And that's pretty much all I have to say. I'm going to sign out for today. Thank you, guys, and have a lovely, lovely weekend. Take care. All right. Bye-bye.